So last week was the first week that I ever was working with Go. And I had super fun. And basically, I started learning Go last week. And we set up a project, right? A URL shortener. Just a real simple project. Just a small API to be able to help you to shorten URLs, right? Go, wait, yeah, here, Go short links. So, let's just take a look at it, right? What is it? It is a URL shortener. Right. And I think it was a pretty fun project. So, it was a pretty fun project. What does it do, right? What does it do? We basically set up two routes, right? We basically set up two routes. One route creates a short link, right? And saves it to the database. One route gets the short link and forwards you to the original URL. So real simple, basically pretty much a normal URL shortener, right? But I think it's a really good project to start off a new language with, because it's such a simple project, so you don't really have to think about the implementation too much. You don't have to think about the details. You can focus on learning the language, right? And I had a great time learning Golang. Golang is a little bit particular, right? It's a little bit particular, but I really enjoyed learning it. It's quite different from Node, but I thought it was great. I thought it was great to learn a little bit of Golang, and I want to keep using it as well. Amsala, welcome in, Amsala. How you doing? Welcome to the stream. Lutefisk, welcome in as well. I'll drop with you guys. So yeah, basically it's a really simple application, right? It's just Emsal. Oh my god, Emsal. I'm sorry, it's Emsal. Welcome in. It's a really simple application, right? But what were some things that I learned as well? So we were using NetHTTP, right? We were using just NetHTTP, which is the native HTTP package in Golang, right? And it was quite nice because I'm pretty used to using Express. So I think that some things that I learned, right? Some things that I learned by using NetHTTP, the standard lib, native standard lib HTTP package in Golang. Thank you, Emsal. Thank you. WGAFA, welcome in as well. Do the short links expire? They currently don't. I hate chemistry. They currently don't expire. But some things that I learned here, right? Some things that I learned was basically that how much that Express does for you, right? I learned how much Express does for you. So basically I learned about, so we had to do our own routing, right? We had to do our own routing, which, I never thought about it before. But we had to do our own routing by method, right? It, by default, NetHTTP only routes by path by default, right? So we had to do our own routing by HTTP method, right? By HTTP method. So we basically built out that. We also, what more did we have to do? So NetHTTP does not do, what do you even call them? But basically, what are they even called? Yeah, we had to parse the params ourselves. We have to parse, does not do URL params, right? So we had to parse the URL params ourselves. Which I think was quite a learning journey, right? It was quite a learning journey, and it was quite fun, I think. We also made Emsal. We also made a .env parser, right? Instead of using a library, we made our own .env parser, which was quite nice. from this, we basically learned, I would say that we learned how to read and parse text files, right? I think it was quite useful, Latif Sama, welcome in. SWCTV, welcome in as well, welcome. Cold Blue Mist, how are you doing? CB, welcome in. So I think we did learn a lot, right? We did learn a lot. Did we learn anything else? I think this is pretty much what we learned, right? So if we just take a quick look at the application. Where's main? Here's main.go, right? And a lot more. We did learn a lot more. Oh, we did learn a couple more things. We did do a couple more things, right? We connected the application to a database, right? The database, doing great. How are y'all? I'm doing pretty good. Happy Saturday, CB. We connected the application to a database, Postgres, right? Postgres. We considered doing this without an ORM. But in the end, we decided to go with using an ORM, right? And we went with the ORM Gorm, right? I think it was pretty nice. I actually thought it was a great ORM. It was quite simple to work with, quite easy to work with, and quite enjoyable. Did I miss some other stuff? I mean, we also had to set our own headers, right? Pretty normal though. Set our own headers. We had to parse JSON, but pretty simple stuff, right? ORM's not great for large projects though. ORMs are not great for large projects. I think a lot of large projects use ORMs, right? But I think Gorm was a really nice project to work with, right? Not in Go. Interesting. That will be interesting to learn more about. I mean, in other projects, we definitely use ORMs a lot in other languages. You might want to add moot.lock unlock at some point when reading right into the database. Right, those are some interesting to-dos, Henry. So basically make sure we can lock the database, right? That's maybe one to do. So I was thinking maybe later today we will look into doing a little bit of refactoring on this actually. I love Prisma with TypeScript. Prisma and TypeScript are great. Prisma. I've been working a little bit with Prisma, and it's pretty nice. Algos, you're getting a new job. Welcoming Trash. Welcome. I'm not looking for a new job. No, I just thought I wanted to have a break, try some new, different types of content. And I know that I suck at algorithms, right? So we're gonna try to do one algorithm later. I'm not looking for a job, but I know I suck at it, so I know I need to get better with it, right? That's basically the thing. How are you doing, Trash? Welcome in, but let's just go through the application, right? It's really simple, right? The first thing that happens is we parse our environment variables. So we built our own custom parser that parses env variables, right? So it takes an env path, and then basically what we do first is we open the file, right? We just open the file, takes a path to the file, which is the env file in this case, and returns a file, right? An OS file. So we panic here. If we can't open the file, we just panic, right? We just straight up panic. But here we open the file, and then we return the file, right? Do we ever close the file? Maybe we close the file later. I think we close the file later. Then we parse the file, right? We parse out the lines in the file. Basically, the lines of text in the file, right? In the parse file here, it takes a file and returns an array of strings. So basically, we read the file here. We put in the file and we read it, and we get out bytes or an error. If we get an error, like normal, we just panic here. Right? And otherwise, here we defer file close. So we close the file here when we're done. Here we basically are just done when we close the file, right? Working out? Were you looking for a new partner or something? Unknown, how you doing? Welcome in. I've not been working out a lot, I can't say that. Still up from the baby shift. Hope you get a little bit of sleep at least, Trash. I think it's concurrency safe. I don't know, we'll see about it. We'll take a look at about it later, right? So here we just parse the bytes, right, into a string. And then we split the strings so we get an array, bam. That's basically all the files in the env file, right? All the lines in the env file. And then we set the environment variables right here, bam. This function takes an array of strings, right, which are the lines in the env file. And then we loop over them right here. And for each line, right, in range lines, we split on n right here. So we basically split. Hey, thank you for the follow, Valdine. Thank you. How you doing? Welcome in. We basically split the strings, right? No, sorry, the strings. This is a freaking standard library package. So we split the line based on equals, right? But we only want 2 parts, right? We only want 2 parts. If the length of the parts is not equal to 2, something has gone wrong. Something has gone wrong, right? And then we just continue. Otherwise, we set the environment variables, right? So real simple. It was fun. For learning purposes, we built an env parser, right? What is the next step in the application? If we just go back a little bit, right? We connect to the database. I think some people were really upset about using DB as a name, so we'll just rename it to con, right? But here we have our own little package, right? We learned about Golang packages as well. It's the first time I've ever worked with Golang, so obviously it's the first time we're working with that as well. What's the point of split n2 if you're gonna validate the length of 2? So basically we don't want to. So if you have, right, what is the point of this? There is a point, right? If you don't split on 2, right? It's possible that you have db url, right, equal https : what? Password equal ask equal user, you know, at something. I can't do an at, you know. It's possible that you have this, right? You can have this. So you have to use the split.2 here, right? You have to use the split.2, I think. And then also you have to check if len is 2, right? Because it's also possible that you have an empty line, or just a line without. It's also possible that you just have an empty line, you know, or a line without an equal even. So it's not a valid line. So basically, this is in order to get the correct thingamajigs, right? The correct env variables out, and not split on the second or third or the fourth equal. And the equal is basically in order to make sure, you know, that we don't parse the empty lines. I would say that that's the reason, right? I think I need to test my endpoints to check if it's safe. Interesting. I've never encountered that issue. Interesting. OXC3B0, welcome in. Makes sense. Good. So basically, these are both handling like edge cases, right? These are both handling for edge cases, I would say. Okay, where are we? We are in the DB thingamajig, right? So here we have our connection with Gorm. We basically get the environment variable that we previously set, right? We previously set this environment variable. And it returns a database or an error, pretty much. If we have an error, if error not equal nil, the Golang way, right? We just panic. Otherwise, we run our little auto migrate with our URL model. So this I thought was actually pretty neat, that it's super easy to do auto migrations. It seems to be super easy to do auto migrations with Gorm, which I thought was nice. So if we go here, right, we have just our short URL model. This is the only model we have, right? We have the URL, the short ID, and the number of redirects. I don't remember what this was called. I think it's like tags. I think it's like struct tags or something like that. And this syntax is a little whack to me, but it's pretty simple. I think it's pretty simple, right? Basically, we just set that a Gorm tag that this cannot be null, and it defaults to 0, right? Pretty simple. Tags, nice. So is this the entire, I think this is the entire DB package that we have, right? So if we just go back and take up, where are we? CMD main.go. Here we go. Let's get rid of that. And this is how you basically register your routes, right? Let's get rid of this. This is basically how you register your routes. So we built our own little router, basically. We had to build our own router, which is this API.method router. So if we basically do a handle func right here, this is how you pass it in with the net HTTP. You basically just have a route and you have a handler, right? But we have to route additionally based on the method. So we had to build our own router based on method, right? So basically this one takes the DB connection as the first parameter and then API.method router input as the second parameter, which is basically, what is this, right? This is just a struct that has, you know, a post, a get, a put, and a delete method in it, right? And here are method router. This takes the connection, right? The DB connection. And it takes the method router input right here. And it returns an HTTP handler func. So it does return a handler func because that's what it needs to return, right? Did he just freeze? Did I freeze? I hope not. I don't think so, right? Did I freeze? Is the internet up and running? Did I freeze? I froze? So sad. You guys are lying, right? No, it's okay. Nice, good. I did freeze? Interesting. Maybe I should turn off my Wi-Fi. Thank you, Pistol Shrimps FPS, for the follow. Froze for like 6 seconds. Jeez. I hope it's better now, though. So yeah, this is a pretty interesting function. I thought this was like a big part of the meet last week, right? Was to write this function. And I was like, oh, this is the kind of stuff that you have to do if you write an HTTP library, I guess. Because this is the kind of thing that I never thought about that you have to do, but of course you have to do it, right? It only takes a handler function, right? It only takes a handler function in HTTP, so you have to do the routing yourself. I thought Internet Swing is the best in class. Well, I'm worried that maybe it's using my Wi-Fi and not my Ethernet. So let's turn off the Wi-Fi. And okay, let's turn off the Wi-Fi. Let's see if we crash. Let's see if we permanently crash now. What are we thinking? 1, 2, 3, let's give it a go. Okay, Wi-Fi is now off. Let's see, are we live? Are we even live? Are we still live, guys? Give me something if we're still live. I don't even know. Yes, we're live. No, Lutefisk, goddammit. So this handler, this is a handler function technically, right? Hello, trash. Hello. This is technically a handler function. I mean, it returns a handler function, right? It takes these two methods and returns a handler function. So what is this function, right? We basically switch based on the method, and then we will try to handle each of these methods. So if we have an HTTP method get, if that's what we're getting, then we try to handle that method. If we're getting a post request, we try to handle the post request, right? If we get a put request, we try to handle the put request. If we get a delete request, we try to handle the delete request. If it's not one of these 4 methods that we're getting, we're throwing unsupported HTTP method, right? Status method not allowed. So it's a little bit interesting, I thought, this switch statement, but we also have this try handle statement, right? So basically what we do here is this try handle takes a function, which is basically a handler, right? And we check if we have a handler. If handler is not equal nil, then we call this handler with the database connection, right? Otherwise, we throw this error again, right? That we have an unsupported HTTP method. We have to do this, right? The guy who designed this method router is smart. I don't know about that. It's like probably the worst homemade jank, right? It's the worst homemade jank of a router, but it had to be done if you working with NetHTTP, right? And so then basically we call the handler. So if handler not equal nil, then we call the handler. That's pretty much the method router, right? So what do these handlers look like? We just have 2 handlers. So we're pretty much done we're pretty much done with this freaking explaining the entire app, right? All of the flow in the entire app. We just have 2 routes here, right? Create short URL and forward URL. So the create short URL here is a higher order function, right? It's a higher order function that takes a DB connection as the first argument and then returns a handler function, right? So we just put it in a closure right here. We just closure it, right? We just closure it, and then it returns an HTTP handler function here. So first, what we do first is we parse the URL from the request, right? We have to parse the URL from the request. So what do we do here? We basically put in a request object, and it returns a string or an error, this function, right? So here we declare our struct. Here we declare our variable, which is this struct right here, right? This URL post body. And we use the JSON new decoder to decode the URL body. So this syntax, I don't 100% understand, right? But I think basically we parse it, put in the body, right? And then we say what we want back. And if it's not that, I guess we're throwing, right? I guess we're throwing an error. And then we basically throw an error if I think it will throw an error if the URL body doesn't match, if the R body doesn't match the URL body. I think so, at least. So if error not equal nil, then we return the error from here, right? We just propagate the error down. Otherwise, we return the URL body.url. Pretty simple, right? Pretty simple. So here we have a URL or error. So if we have a nil, right, we just pass bad request, right? Because we tell the user, nah, this doesn't fly, fam. Otherwise, we generate a short ID, right? And this, I think, needs to maybe be refactored a little bit. But we basically, well, not this specific function, but this entire flow, right? This entire flow. But here we generate the short URL. So we wrote a small little algorithm that basically generates a short URL. Takes, you know, nothing as an input right now and generates something with all these characters inside it. So here we make a short URL that is an array of bytes, of 6 bytes, right? It's an array of 6 bytes. We create a random seed based on now. I don't 100% understand this, but I don't know if we need to, but we basically create a seed for new random, right? We basically create a seed based on right now. And then we pass in the seed in ran.new, which I think returns a function, right? And then we basically iterate here 6 times, and we get a random number here in the randomizer .int number, I think, which is the length, right, of the characters. So we just get a random characters from this array, right? And then we plonk out the character right here. And then we put it in our short URL, which is already an array of bytes. This is already an array of bytes. And then we stringify it, right? We stringified it. Bam, we have ourselves a short URL. Bam, very easy. You probably need to rename seed to source. It doesn't make sense. Doesn't make sense. We can do it. No, it is a seed, right? Isn't it the seed? Isn't it literally what it is, right? I'm not sure. But here we have a short ID, and I have no idea what's happening here. Trash. Honestly, neither do I, right? Neither do I. I don't really understand. But basically, this is basically all of this stuff is a math.random, right? Basically, this is a math.random. We have to create our own math.random. Otherwise, math.random isn't random, right? I think that's the problem, right? I'm just not familiar with the built-in stuff. Yeah, pretty much, right? So here we initialize a struct. So we have short URL input. So we basically just initialize a struct here. This is just our struct model. We just initialize it here with a short id, the URL, and redirect 0, right? And we pass it into our method here, short url.save. Short url.save, very simple function, just takes a DB connection, right? And a short URL. So the first thing we do, right, is we check if we already have one. So we find by URL, right, which is a method. It basically also takes the connection, right, and a URL, and returns a short URL model or an error. So here we declare the short URL model, and here we basically, so this function mutates this variable, right? So connection.where URL equal URL, pretty much. We're just doing a search based on URL here. And we are plonking the first one. We're taking the first one, right? And we're basically mutating this variable. I think we're passing some sort of pointer here or something. I don't even know, but we're mutating this variable we declare right here, right? And we're returning an error right here, so we're plonking out an error. And here this function basically returns a short URL or an error. Very easy, very easy. So here we have an existing short URL or an error. So if error not equal nil and errors.is, so if the error is not record not found, then we would just return the existing. So if error not equal no and errors.is gorm record not found, shouldn't it be like this, right? Shouldn't it be like this? I think it should be like this, right? I don't even remember. But basically the idea here is that we should check. No, right. We have, no, this is true. This is correct, right? This is correct, right? This is correct. We're basically just propagating the error, right? If the error is not record not found, we're propagating the error. So this is correct, right? Here we're handling the existing case, right? If we already have an existing case, because this is pretty normal. It's pretty normal that we're gonna get record not found. We wanna get record not found when we're creating something, right? So if we already have an existing one, then we return it, right? Then we return it. Pretty simple, I think. So if we don't have one, right, then we basically pass it into connection.save, right? The method is called new source. What would it return? It's a mystery. Oh, maybe it's the source, right? Let's see this argument you're passing to new source. I guess it probably returns a source. You guys are probably right. You guys are probably right. It does. I guess it returns a source, right? Where are we even? New source? Ah, maybe you guys have a point. Source. It does return a source, I guess, right? I think you want to return nil error, then if error is not error record not found. Well, this returns a short model, right? So we can just propagate it, I think. We can't, I think it will complain, right? Yeah, cannot use nil. No. So we're just propagating what we're getting from here, right? We're just propagating it. So this is the, oh no, this is not what we're doing, right? Ah, we're on the save function already, right? So yeah, here we're saving it, right? We're returning the error. So here we're just reassigning the error variable. We're just reassigning the error variable. And here again, we print an error here. If we get the error, we just add a print and then we return short URL and error right here. Where's this being called, right? Where's this being called? Right, it's being called right here. So if we have an error here, then we respond with the internal server error because something went wrong that isn't supposed to go wrong, right? Here we respond with an error. So this HTTP error takes a writer, an error, and our HTTP code. If we get here, things were successful pretty much, right? Star Lord GG, thank you for the follow. I appreciate it. Welcome in, welcome in. How you doing? How you doing? Welcome in, welcome in. Yeah, if we get all the way here, pretty much successful, right? Here we set the content type to application JSON. Here we basically set the headers. You have to do this manually when you don't use a higher order library, right? Which is fine. And here we basically have to encode the JSON again, right? So here we take the JSON. No, here we're actually sending it as well. So JSON.newEncoder takes a writer, right? It takes a writer, right? Don't you need a return after HTTP error? I do need a return there. Good catch, Henry. Good catch. Yeah, I do need a return there. Or does HTTP error end execution? I shouldn't know. I don't think it ends execution, right? Maybe it does. I'm not sure. I'm not sure if this ends execution actually. But probably it doesn't, right? Probably it doesn't. There's nothing that tells me that it does. So Because right, you might, yeah, you have the right to do whatever you want afterwards, right? If you want to save something, some metadata about the error, I think so. So this should not end the execution. So you're right, we need to have this return statement here. Felix Moreno, thank you for the follow, I appreciate it. Welcome in, welcome in. So we set the headers here. Here we're sending the response, right? So JSON.newEncoder takes a writer here, which is our response object basically, and we encode the short URL, right? Easy peasy. And if we have an error doing this, then we HTTP respond with the error basically again. We just bad request it again. Maybe we should internal server error it. I don't know. Probably we should internal server error it. Right? Bam, smack. That's basically what happens. Very nice, very nice. So that's the create short URL, right? If we go back to main.go, we just have one little puny method left, right? And that's the forward URL method, right? So here we gotta do some fun stuff, right? Again, I'm a huge fan of the HTTP status variables. Hey, thank you, thank you. That's awesome. I'm glad you like it. Makes it super easy to read. Which ones do you mean? Do you mean like this ones? These ones? I'm glad you like it, I'm glad you like it. I thought it was pretty janky, but we just came up with it because we had to do something, right? We had to do something to make it work. And this was, I guess, for me, the easiest way to do it, right? The easiest way for me to do it. I'm already out of coffee, it's very sad, right? So here we have the forward URL, right? It takes a database connection, which is a Gorm DB, right? Returns a handler function, like normal. We always have, no, you mean HTTP status not found. Yeah, I agree with you on that, actually. I 100% agree with you. They are great. They're great to work with. I mean, all these errors are great. It's very readable, very readable. I love the typing actually in the standard lib. I love this typing in the standard lib. It's so good and it's so easy to follow. Actually, like the standard lib is quite good, I would say. But this is the forward URL, right? We basically parse the ID. So here is where we parse the URL parameters, right? I don't know if this is the optimal way to write it, right? But we basically taken a request and we snap out the path here from the URL. Cafe Vienne Noise, welcome in. How you doing? Welcome, welcome. Cheers. Hope you're having a good Saturday. Let's drop with cafe. So yeah, here we're basically plonking out the path, right, from the rec.url. And here we just trim the prefixes just to be sure. We trim the suffix and the prefix just to be sure, right? And then we plonk out the path, right? We just take out the path here. Then we just take out the path. And this is supposed to be the ID, right? This is supposed to be the ID. This is supposed to be the ID, so we get out the ID from here. And then we gotta just find it. We gotta find by short ID, right? We gotta find by short ID. So what we do here is we basically take in a connection again and a short id, right? And we turn a URL model, short URL model, or an error, right? Here, same as before, right? We do a find, right? We basically pass in the, but instead of finding by URL, right? We are finding by short id, right? So here we're declaring our, we're initiating our struct, right? I missed the pool. Yeah, it's very sad. GG though, Henrik. GG though, winning the drop. Here we're basically initializing our struct, right? And then we basically try to find the short ID, right? The short URL from the database, where the short ID equal this short ID, right? And we take out the first one. Here we're returning the error. So this one again is mutating the short URL that we instantiate right here, right? Returning the short URL or the error, right? I think this should probably be short URL based on what it seems like is the standard. So that's what this function does, right? And here we basically check if we have an error that is error record not found. We throw the status not found error, right? Very easy. Like this is the beautiful thing with the standard library, right? These ones are great. These ones are great. And here I did the right thing, right? We did the right thing. We throw out an early return, right? If we have the error, if the error is not nil, right? We throw a status bad request instead, and we return. Otherwise, here we're doing the redirect. Here we're doing the redirect with existing.url, right? Which is the URL. Oopsie. Which is the URL. it takes the writer and the request, the existing URL, and here is the response code, right? So here we're throwing a status temporary redirect, a 307. We were initially throwing sending a 301, right? But then I could never redo. It would like cache forever the redirect in the browser, right? So I could never do the redirect again. And the problem was then that we wanted to increment our redirects. We wanted to have analytics on how much our redirects are being thrown, right? We wanted to know how much our redirects are being thrown. Are being done, how many redirects we're doing. So we just never came here because since we were doing a 301 right here, we just never came back to the handler function even. The browser was just doing it for us. So we had to change it to a 307, and now we are getting to the increment redirects, right? Now we're getting to increment the redirects. And here, we're basically just adding redirects +1, right? We're printing some stuff that we probably don't need to print, right? And that's fine. That's fine. And here we're doing a debug. We also don't have to do the debug, right? We don't have to do the debug. We're passing the short URL here, right? It's a model. And we're finding by ID and updating redirects and returning the error, pretty much, right? Very easy. We could consider to do the same thing in the other function as well, doing the update directly in the read, but that's something we will consider later, pretty much. But that's the entire application, I would say. And if we have an error right here, if it's not equal nil, then we print line, then we just print the error, right? Maybe we should do this as well, right? What do you guys think? Maybe we should just do this as well. And do like a internal server in status internal server error, right? Wait, why doesn't my autocomplete work? Right, now, there we go. There we freaking go. I have a diagnostic, right? No FMT. Very nice. So that's pretty much the application. What do you guys think? I thought it was really fun, right? I thought it was really fun to try to learn Go. I thought it was very educational, and I want to keep using it. And I want to come back today, actually, to see if we can rewrite this in Gorilla Mux. I've never used Gorilla Mux, so it's gonna be really, really fun. What do you guys think? But yeah, thank you so much for listening.